Welcome to The Explainer. Imagine trying to teach a machine to understand a language that's not just spoken, but seen, a language of movement, expression, and space. Well, today, we're diving into a really exciting breakthrough in AI that's getting closer than ever to cracking the code of sign language. Okay, so let's just jump right into it. Why is this so incredibly hard for computers? I mean, we have translation for spoken languages, right? To really get why this new research is such a big deal, you first have to understand what makes sign language so uniquely challenging for an AI. And that brings us to the first major hurdle, what researchers call the Sign Language Recognition Challenge. As you'll see, this is about way more than just teaching a computer to recognize what shape a hand is making. Think about it like this. A spoken language is basically one stream of information, right? It's audio. But sign language, it's like a movie with multiple streams all playing at once. You've got the hand gestures, sure, but you also have body movements. And, this is critical, facial expressions, which act like grammar and tone of voice. And then, on top of all that, you have regional dialects, just like you would with English or any other language. It's just so incredibly rich and complex. And all that richness, well, it's been a massive roadblock for AI. The older, traditional models, they were okay with static images or maybe some simple movements, but they just couldn't handle all these different layers of information happening at the same time. The result? For years, progress in this field really just stalled out. So, how did these researchers finally break through that stalemate? Well, it started with solving a really basic, fundamental problem. You could call it the missing data puzzle. Because at the end of the day, an AI is only as good as its teachers, or in this case, the data it learns from. You see, a lot of the existing data sets were, well, they were a mess. Imagine you're trying to learn a brand new language, but your only material is thousands of random, low-quality video clips you scraped from the internet. Different people, different lighting, shaky cameras. That was basically the situation with older data sets like WLSAL. It's like trying to learn in a super noisy classroom. It's just really hard for an AI to spot the important patterns. So to fix this, the researchers said, okay, we need to build a better classroom. And that's exactly what they did. They built a brand new data set completely from scratch. They brought in 10 native deaf and hard of hearing signers and filmed them in a perfectly controlled lab setting. Same lighting, same camera angle, everything clean and consistent. And the result of all that work? 10,000 absolutely pristine video samples. This wasn't just more data, it was better data. They basically created the perfect state-of-the-art learning environment for an AI, giving the entire research community a powerful new tool to build much smarter systems. Okay, so having amazing data is step one. But that's only half the battle. How do you actually get the AI to learn from it in the smartest way possible, especially when the subject is this complicated? This is where the researchers did something really brilliant. For the first time ever in sign language recognition, they used a strategy called self-paced learning. The idea behind it is actually super intuitive and powerful. You teach the AI the same way you'd teach a person. I mean, think about it. You wouldn't start a first-grade math class with calculus, would you? Of course not. You'd start with 1 plus 1. This is the exact same principle. They first showed the AI the easy signs, the ones that were super clear and distinct. Once the model got good at those, they gradually introduced the harder, more subtle signs. It lets the AI build its understanding layer by layer, from a solid foundation up. But even a smart learning strategy isn't quite enough by itself. The AI also needs to be able to look at all the evidence it can get from the videos. It has to act kinda like a detective, piecing together all the different clues to solve the case. And this is what's known as a multimodal approach. The AI detective is basically looking at 3 types of clues at the same time. First, you've got the RGB frames. That's just the plain old raw video. Second, there's optical flow, which is like a motion detector that highlights how things are moving from one frame to the next. And third, you have skeleton data, which creates a digital stick figure of the signer, tracking the precise movement of every joint and bone. Now here's the really amazing part. The AI wasn't told which of these clues was the most important. It had to figure that out all by itself. And as you can see, it actually learned to weigh the evidence. And it decided that the single most informative clue, the one it should pay the most attention to, was the movement of the bones. That's pretty smart.
So, this is the crucial moment. What happens when you combine all three of these amazing innovations? You've got the super high-quality data, you've got the human-like learning strategy, and you've got this multimodal AI detective. What do you get?
You get a massive leap in performance, a huge one. On this new, tough dataset, the best of the old models was topping out at around 77.5% accuracy. But this new, combined approach, it jumps all the way to nearly 90%. In the world of AI research, that is a ginormous improvement. That 12.3% jump might not sound like a world-changing number on its own, but trust me, in this field, for a problem this hard, an improvement of that size isn't just a small step forward. It's a pole vault. It's a genuine game changer that pushes the entire field into new territory.
And this really matters because it's not just about getting a better score in a lab. This is the kind of accuracy that starts to move AI-powered sign language translation from a cool academic idea toward a reliable, real-world tool. A tool that could one day truly help bridge communication gaps and make our world so much more accessible for the deaf and hard of hearing community.
Now, let's be clear, this research was focused on recognizing individual, isolated words. The next huge mountain to climb is teaching AI to understand continuous, fluent conversation. But this work creates such a powerful foundation, it leaves us all with a really exciting and hopeful question. Is AI finally truly on the verge of breaking the sign language barrier?